Hi folks, Mrs. Sid here. We are going to be doing some intro to logarithms today. Um, Very exciting. We didn't get to this on Friday. So I'd like to give you a little preview of what logarithms are, and you do have an exit slip to hand in. So notice that one sheet. So hopefully this won't be a very long video and you can get onto that exit slip and earn 100% and of course improve your grade. So let's get going. Logarithms. For perhaps many years now, you have not been able to solve if x is in the exponent. We've been doing a little bit of that, but that 2 to the x equals 24th equation from Friday kind of put a little wrinkle in things. We couldn't do that because we couldn't write 24 to a power of 2. So in comes a solution. If we have b to the x power equals a, that can be rewritten as a logarithm. Woohoo! So the base of the exponential is b. Logs have bases too. It will also be base b. The argument of the log is a. And here's the cool part. A log equals the exponent. So notice how the log equals x, and x is the exponent. Now, this little arrow back and forth means we can go from an exponential to a log or a log to an exponential. So either one is going to be helpful, depending on the problem. Now, a little side note here. Let's talk about some restrictions. We have that a has to be bigger than 0. So a is always going to be some positive number. Notice it can be a fraction, it can be 1, it cannot be 0. That would be bad. B has a couple of restrictions. Like a, b is bigger than 0, but b cannot be 1. The reason we don't like b being 1 is if you think about the exponential form, 1 to a power is pretty boring because it's always 1. So b can be any positive number. It can be a fraction. It's not going to be negative, and it's not going to be 1, and it's not going to be 0. Notice no restrictions on the x. That can be anything. So this may come up in our work. I just want to point it out. Okay, the first few is just converting between the two forms. So going from a log to an exponential, from an exponential to a log. So we're going to start by looking at an exponential. So if I follow this format, if the base of my exponential is 2, I'm going to write log base 2. And now what I often think of is the 2 and the 4 are on the same side here. So they're going to switch sides. That means I'm going to take the log base 2 of 16 equals 4. Remember, the log always has to equal the exponent. Okay, that may have seemed like magic, but it does take some practice. Let me show you another one. So I have 10 squared equals 100. So the base is 10, so I'm going to do log base 10 of 100. And that should equal my exponent of 2. So log base 10 of 100 equals 2. One more to convert to log form. And maybe you want to pause the video here and see if you can do it, and then check based on what I've done. So let's put this into a log. This is going to be log base 2, because the base of the exponential is 2, of 1/4 equals the exponent. So log base 2 of 1/4 equals -2. All right, so now we're going to go in the opposite direction. We're going to start with a logarithm, and we are going to go back to an exponential. want to be able to be fluent to go either way. So this is just practicing. We're not solving for anything, just like we were not solving it with anything in number 1. So let's take a look. My base of my log is 3, so that's going to be the base of my exponential. The log equals the exponent, so this is going to be 3 to the 4th equals 81. 81 is the only other number I have there. Right, part B. The base of the log is 5, so I'm going to do 5. The 2 is going to be the exponent because I know a log equals an exponent. And 5 squared equals 25. Notice that statement makes sense. Same thing in part A. This statement makes sense. 3 to the 4th equals 81. Like, yeah, I could check that. 3 to the 4th does equal 81. 5 squared is 25. Now this last one here you can't check because we have a B, but I'm going to start with that base of B, raise it to the 3rd power because a log equals an exponent, and that'll equal 512. We're not going to solve till we get further down on the page. For right now, it's just converting between the two. This might be a good point where you want to pause your video and go do the first 2 problems on the exit slip because they are just converting between a log and an exponential. Okay, let's take a look at how to solve log equations. So, how to solve a log equation? Well, let's do some steps first. First, we want to isolate the log. Step 2, undo the log using exponential form. So basically switch it back to an exponential. And then 3, solve for the variable. Now the log equations we're going to look at today are pretty straightforward, but of course they can always get harder. So let's take a look at 3 examples. All 3 of them, let's see, so all 3 kind of have you solving for different parts. So let's take a look at when solving for the base. So let's just look at, say, log base x of 100 equals 2. So since logarithms are pretty new to us, what I would recommend doing, and the log is by itself, by the way, is rewriting this as an exponential. So my base is x, my exponent is 2, and that will equal 100. So x to the 2nd equals 100. Well, if I square root both sides, don't forget that plus or minus. When you square root, it always becomes an absolute value of x equals 100, or sorry, equals 10. So that's why x equals plus or minus 10. But if you remember way up here, that the base has to be a number bigger than 0. So that means my answer is really just going to be the x equals 10. Now let's take a look if the variables in the argument. Quick example is log base 5 of x equals 2. Okay, so my first step is to rewrite this as an exponential because the log is already isolated. So I'm going to start with the base of 5. 5 is going to be raised to the 2nd power because the log equals an exponent, and that equals x. So 5 squared equals x. Oh, that means x is 25. And then last one, if the x is the exponent in a log, then it's going to look like this. It's going to be log base 2. I did not write that well. try it again. Log base 2, say 1/4, equals x. So if I rewrite this as an exponential, which is kind of the step 2 over here, undo the log, it would be base of 2 raised to the exponent of x equals 1/4. And now this feels like something we did on Friday, right? 1/4 I can rewrite as 2 to the negative second. So this is really x equals -2. Okay, let me do 3 more examples with you, and then you are off to do some problems on your own on the exit flip. Okay, the first one in number 3 there, notice we're solving for the arguments. That's a lot like this blue one here. So I'm going to rewrite it as an exponential. Base is 2, exponent is 3, and that's going to equal a. So that means my a is 8. Right, letter B here. Notice how my variable is now in the base. So it's like this first problem we did up here. So I'm going to start with that base of B, raise it to the second power, equals 49. When I square root both sides, I get B equals not just 7, but plus or minus 7. But we know the base can't be negative, so we're only going to take that positive 7 as our answer. Right, folks, last one here. B is, again, the base. So it's like that first one in green. So I'm going to write this as B to the third power. So base to the exponent equals 64. So how the heck do I solve this? Well, if you remember on Friday, we had this box of numbers to remember. It's actually in there. Or you can do a cube root on both sides. But B ends up being 4 because 64 is 4 to the third. Okay, so that's just a small introduction to logarithms. I hope that made sense. If not, bring questions to class on Wednesday. You have an exit slip. It's worth 5 points. So you're doing 2 conversions like we did up here, and you're doing 3 equations. So a total of 5 points. Have a wonderful day, folks. I will see you on Wednesday.